All right, guys, what you are about to watch is the video explanation of the test review guide. If you just want a quick check to see if you're right or wrong, there's an answer key posted on Canvas and on the backboard, so you can use that. This is more for like you're not understanding why you're wrong and you need an explanation. So starting with questions 1 through 5, I'm using this diagram here. And the first question wants us to give 3 other names for plane P. So I've got to locate the P. Right, so here's plane P, and it's this shape. When we are naming a plane, we need to pick 3 letters. Those 3 letters can't be in a line. So you can't call this plane EDG because that's a straight line, like EDG is not the name of a plane. When you're naming a plane, you want to think about, if I pick these 3 letters, would they form a triangle? If your answer is yes, then you've named the plane. So for example, I could do E, D, F, because if I were to connect E, D, and F, that would form a triangle. Okay, so that's one way to name it. I could do D, G, F, because if I were to connect D, G, and F, I'd get a triangle, so that's another way to name it. I could just skip D altogether and do E, G, F, because that's a triangle. What I can't do is something that's in a straight line. I can't use the letter N because it's not a point, so you can't use that, okay? You could also do any variations of these letters, like mixing and matching them. So that's just 3 different ways, but you could rearrange the letters and get plenty of other ways to name this plane. For the next one, it wants us to name line M. So line M, if I find the letter M, line M is this path, okay? So to name a line, I just need to pick 2 points that fall on that line. There are actually only 2 points that fall on line M. So there are actually only 2 other ways to name the line. We could use the points D and B, or the other way, B and D. And then in order to get full credit for a problem like this, you would need the right symbol. The symbol for a line is a double arrow on top of your 2 points. Right, so that's 2 different ways, the only 2 other ways to name that line. Is ray DG the same as GDY? All right, so let's look at ray DG. So D goes to G. In blue, that's DG. So it starts at D and it heads in this downward right-hand direction. Ray GD starts at G and heads towards D. So it goes in the upward left-hand direction. So the answer to this question would be no. More specifically, they start at 2 different places. So they have 2 different starting points. One starts at D and one starts at G. And they also have 2 different directions. One goes left, one goes right. They are not the same way. All right, number 4, name 2 segments that contain the point A. So let me find the point A. Here's the point A. A segment could start at A and stop at B. And the symbol for a segment looks like this. So that segment is that one. A different segment could start at A and keep going and stop at Z. So we could say A, Z. These are our 2 segments. What you could not say for this one is AB and then BA, because those are the same segment. So that would just count as 1 segment. You couldn't say AZ and then ZA, because that's the same segment as well. So that's the second one, right? Those are 2 different segments. So you would need 1 of each of those. 1 from the purple, 1 from the black. Line M is a segment bisector to AZ. So let's kind of draw out what that looks like. Line M we talked about as this up and down line. and it's cutting AZ. So here's A, and here's Z. So line M is like the knife that's cutting this line AZ into two parts. So there's the left-hand part and the right-hand part. So if M is a bisector, it's saying that this side is equal to this side. So this question is saying, what are those two equal parts? Well, this has point A and then this middle point, which is B, or BA. And then the right-hand side is BZ or CB. So these are the two equal parts if line M is a bisector. So this is review from the beginning vocabulary. For questions 6 through 9, use the diagram at the right. So the first thing that we're working with is angle PCN. So I'm going to just trace the letters in that order. PCN is this slice, okay? Think about this picture as like one big pizza. So we've got this red slice. And then I want to find something complementary to that red slice. Complementary means that it makes a 90-degree angle. And 90-degree angle means that you need to have this box. So my complementary angle would be this one, because together red plus blue make up that 90-degree angle box. So I just have to name that blue angle, and I would call that LCN, or you can reverse the outside letters, NCL. Either of those two would create that 90-degree angle box. For the next one, I'm just going to redraw the picture so I can mark up another picture here. So sometimes it helps to draw this more than once. All right, so here's what we've got: N, C, P, R, T, and L. All right, and I'm going to draw my pizza out of this. So the first angle that I have here is TCR. So TCR is this slice right here. And I want something to be supplementary to this, which means I wanted to make a 180-degree angle. A 180-degree angle is a half circle. So think about this knife coming in and slicing this in half. The top half makes up 3 angles, the bottom half makes up 2. Supplementary is a pair. So one possibility would be this angle here, and we call that RCP. Or you can reverse the outside letters and say PCR. Another way to look at this would be to slice it up and down. So if this was the slice, the left-hand side has 3 angles, the right-hand side has 2. So that orange angle could work as well. So you could have also said angle TCL, LCT. Either one of those answers is supplementary to that given angle. For the last one, I'm going to redraw the picture again. I think it's helpful to mark it up. Just kind of writing in all of the letters. And then I'll mark up what I have. LCP. LCP. Is that big angle. All right, and I want to do something vertical to that. So vertical would mean that I want across from that. So thinking about the pizza, the slice that's not next to that one would be this one, right? It's a not next to, it's across from. So this angle would be TCR, or maybe you call it RCT. Just a kind of a pro tip here, I think it's helpful to draw the picture out multiple times and mark it up rather than using a pencil and you have to keep erasing. All right, so this one says that we have NCP. So this angle here is 25 degrees. They want us to find NCL. NCL. I know that the purple and the red angle are what's called complementary because they make that 90-degree box. So I can do 90 minus 25 to figure out what the remaining part of that angle is. So that would be 65 degrees. The next angle they want us to find is angle TCN. So let's see. TCN is this big orange angle. It might be helpful to see those two angles without that middle line. So if this is P, this is C, L, T. So if I have this angle here, the orange angle is this big angle here. I think in this picture it's more clear that this is the half of the pizza. So this is a linear pair. So together orange plus purple make a 180 degree angle. So I can do 180 minus that 25 degree angle to get 155 degrees for this one. And then the last angle here is TCR. TCR. TCR is actually vertical to this box. So that would mean since vertical angles are equal, if that angle's 90, then the opposite angle would be 90 as well. Or you could think of it as vertical to the 65 and the 25 together, which is 90 degrees. Using the diagram on the right, ray OB, this ray, is an angle bisector. Bisect means cut in half. Bisect creates two equal parts. So angle 1 is equal to angle 2 is what the bisector is telling me. Using the following information, find x. So AOB is 5x plus 12, and COB is 13x minus 20. So those two angles are equal. Okay, angle 1 equals angle 2. So I'm going to do 13x minus 20 is equal to 5x plus 12. And then I can just work my way algebraically through this problem. I get 8x minus 20 equals 12. I can add the 20. 8x equals 32. X equals 4. Sometimes these problems might ask you to plug back in and solve for missing angles, but in this case, it's just asking me to solve for x, so I can stop there. Using the diagram on the right, solve for x. This is a triangle. I know that the three angles inside of the triangle add up to 180 degrees. So angle 1, I call x, 8x plus 2. Then I have 9x plus 3. This third angle doesn't have a measurement on it, but that box is telling me that it's 90 degrees. So I'm doing angle 1 plus angle 2 plus angle 3, which is 90, equals 180. So 8x plus 9x is 17. And then 2 plus 3 plus 90 is 95. And now I'm just going to combine like terms on opposite sides. And divide out this 17. So my answer for this problem would be x equals 5. Sometimes it might ask you to find another angle, but in this case it just says solve for x. Use the diagram on the right to solve for x, y, and z. This one's a little bit tricky. When I look at this question, I'm actually seeing three different triangles. So I see this triangle here. I see this triangle here. And then I see this big triangle. So what I'm going to do is I'm going to draw each triangle out and fill in what I know from each part. So here's my red. I've got an X, a Y, and a 40. Here's my blue. I've got a Z, a 57, and a 24. And then my pink is my big one. So the left upper hand corner is X. The right upper hand corner is 57. And the bottom is both 40 and 24 combined. So it's a 64-degree angle. Just know that in math, you can't solve an equation with two unknowns. So the only one of these three triangles I can't work with right away is the red one. So I'm going to start at blue. I know that the three angles inside of a triangle add up to 180 degrees. So I can set this up. I can combine my like terms. And just work my way through the problem to solve for Z. And that's 99 degrees. So I've got Z. I can also work with this pink picture because I have two of the three angles. X, 57, and that bottom angle is those two angles combined, which gets me 64. So I have, when I combine my like terms, 121. And then I can subtract the 121 to get that X is 59 degrees. So now the only image that I have to work with now is this one, but I actually know now that Y is 59 degrees. I got that from the pink triangle. So now I do have two of the three inside angles of this triangle, and I can set it equal to 180. So I end up with X plus 99 equals 180. And then if I subtract 99, I should show, if I subtract 99, I end up with X equals 81. So a little bit tricky. You kind of have to break that apart with what you know, but those are the three answers for that one. Use the diagram on the right to solve for angle E. I know that in a triangle that has an outside angle, the inside angle plus the inside angle equals the outside angle, as long as the inside angles I'm working with aren't next to. So as long as I'm not working with the one directly next to the E. And I'm not, so this would work out. I have this inside angle of 60 plus this other inside angle of 69. Those two together would equal the outside angle, which is called letter E. And 60 plus 69 is 129 degrees. So E is 129 degrees. This deals with the same relationship. My inside angle plus my inside angle is equal to my outside angle, as long as I'm not dealing with the one directly next to it, which I'm not. So X plus 25 plus X plus 17 is equal to the outside angle, which is 3X plus 2. If I combine my like terms, X plus X is 2X, and 25 plus 17 is 42. I have X's on both sides of the equation, so I've got to work on combining them. And then subtract that 2. So 40 is equal to X. This problem just says solve for X. It doesn't ask me to then plug this back in and get any other angle, so I can stop there. For this next one, we just have to work with angle relationships. And so I'm going to highlight each angle and then talk about their relationships. All right, so if I highlight angles, oops, I need to unfreeze my screen. If I highlight angles 3 and 7, so I can identify their relationship, when I go to highlight angle 3, I notice that angle 3 is below line L and to the left of line N. And angle 7 is below line M and to the left of line N. So they're both below and to the left, which makes them what we call corresponding angles. These are angles that are in similar positions on the picture. These are my bottom left angles. So those are gonna be corresponding. Let's erase this and start again. So I'm looking at 1 and 8. If you're thinking of line L and M as like our sandwich, right? Like this is like our hamburger, 1 and 8 are the bun. They're on the outside. So they're called exterior angles. And they're also on different side of what's called our transversal. That line N is slicing the picture into 2 sides. 1 is on the left and 8 is on the right. So that's alternate because they're on different sides of that line, and exterior because they're on the outside. So these are alternate exterior angles. Clear this out. 4 and 5. 4 and 5 are on the hamburger, the meat part of this sandwich. So they are inside angles. They're being tracked in by lines L and M. They are on different sides of that diagonal line, which makes them alternate. So we call this alternate, but these two are interior angles. Angle 4 and angle 6 are interior angles. They're on the insides of those lines, but both are on the right-hand side of that diagonal. So these are same side interior angles. Let's see. 2 and 8 are exterior angles. They're not being tracked in by any lines, so these are exterior. They are also on the same side of the line, the diagonal line. They're on the right. So these are same side exterior angles. And then finally 2 and 3. 2 is an exterior angle and 3 is an interior angle. We don't have like alternate interior / exterior angles. These angles are actually across from each other, and you can see they're both obtuse, which would mean that they're close to being equal. If not, they are equal in fact. So these are from the beginning of our unit, and they are called vertical angles, opposite angles that are equal. Use the diagram at the right to find x and the requested angle. So when I see a picture like this, I like to redraw it because there's actually more to this picture than I need. This is the part of the picture that actually has information on it. That line over there, AB, doesn't give me anything. The other thing I like to do is extend these lines, because then it looks more similar to a transversal picture we're used to. I think by doing that, it becomes easier to recognize that these are same side because they're both on the left, and they're interior because they're on the inside. And the relationship is that same side is supplementary, so these two angles will add together to equal 180. So I'm doing 9x plus 14 plus 11x plus 6 equals 180. So in this relationship, I'm going to combine my like terms. So 9x plus 11x and 14 plus 6. Just for room's sake, I'm not going to show it, but I'm going to subtract the 20. And that's going to give me a 160. And then I'm going to divide by 20. That's where this 8 is going to come from. Now, when I'm going to find DCB, C is the important part of this. I am looking for angle C. So I'm going to do 11 times 8 plus 6, or 88 plus 6. And that's 94 degrees. So that angle there is 94 degrees. This diagram is giving me a top right-hand angle and a top right-hand angle. These angles are in similar positions. I call them corresponding angles. And I know that corresponding angles are equal. So angle 1 is equal to angle 2. So I'm going to take the equation for the first angle and set it equal to the equation of the second angle. And I want to work on getting the x's on the same side of the equation. and the non-x's on the same side of the equation. And just working my way through this picture or this algebra problem to get x equals 8. Now when I'm solving this next one, remember the middle letter is the important one, and the middle letter for this one is s. So I'm looking to find angle s. So I'm going to do 10 times 8 plus 46. So 80 plus 46. So my angle is 126 degrees. For problems like this, and this is a typo, I don't know if it says this on your paper or not, but it should say 18 through 20. All right, so for problems like this, I like to redraw because there's a lot more information in this picture than I need for each given problem. So for this first one, I'm going to redraw the two lines that make angle 2. So this is this up and down angle and this side by side angle. So or this line, so this is like C and E, and angle 2 is right here in that picture. And then angle 11 is down here, so it's this downward line, and angle 11 would be on the outside like that. So taking that picture apart, I can see that my parallel lines would be the E and the F. And my reasoning would be the relationship between 2 and 11. They're both outside angles, but they're on different sides of that straight line. So because alternate exterior angles are congruent, then the lines are parallel. So my description is just explaining what that relationship is. I'm going to do that same thing for the next one, but I'm going to draw the picture that makes angle 4. So the lines that make angle 4 are E, or C, sorry, and E, and here's 4. And then angle 7 is from this line, and here's 7. So I can see from this picture that my parallel lines are C and D, the up and down lines. And the relationship between 4 and 7 is that they're on the same side of that transversal, and they're interior angles. And same side need to be supplementary. So the explanation would be the angle relationship. And then finally, the lines that make up angle 10 are down here. So here's my 10. So that's F and C. And angle 14 is coming in from over here. And so by redrawing that picture, I can see my parallel lines are C and D. And the relationship between 10 and 14 is they're both above the transversal, but they're both on the right. So these are corresponding angles, and corresponding angles are congruent. Finally, with your midterm coming up, I wanted to throw a midterm spiral question. This is something that you would see on like an open-ended section of a midterm exam. So in the very beginning of the semester, I taught you what's called the substitution method. And I said, in order to do the substitution method, you want to look at the numbers in front, the coefficients. The only equation here that has something without a coefficient is the bottom equation, and the x is alone. So we want to solve this equation for x by getting rid of the 2y. So I do the opposite of minus 2y. So I end up with this x equals equation of 2y plus 4, or 4 plus 2y. Then I'll go to the equation I didn't use yet. And in this equation, I can take out x because I know something that x is equal to. So I'll take out that x and I'll plug in what x equals, which is this. Everything else about this equation is going to stay the same. You'll know you did substitution right when your entire equation is now just y or just x. In this case, it's just y. So I am distributing my 5 I'm gonna combine my like terms. 10y plus 6y is 16y. And if I can subtract that 20, I get 16y equals 48. And if I divide 16, I end up with y equals 3. A lot of times kids stop there, but the solution to a system is an x and a y. I always suggest going with equation 3, which is your newly created equation, but any of them will work. So I'm taking x equals 2y plus 4, but now I know that y is 3. So x equals 6 plus 4, x equals 10. The solution to your system is a coordinate point, x, comma, y. So 10, 3. Hopefully this helps. We have a unit test on Friday, so we will review again tomorrow in class, and then your unit test is Friday. At this point, you should be working on your Math Excel if you didn't do that already.